This
Are we on
conference will
record?
now be recorded.
Great.
Good
Thanks,
morning.
everyone.
Thank you. Coming back to again thank Improving. Improving has been a supporter of DMC in Calgary since our inception in 2017. And actually, Brianna Loughlin is here to give you a welcome as well. Brianna, go ahead.
Thank you. We're really happy to be the sponsor here today. So thanks so much for this opportunity. As noted, I'm Brianna with Improving. I'm the Business Development Manager in the Calgary office. We are such a proud Calgarian team here. We've actually been in Calgary for over 25 years, but we were formerly known as a different name. And we joined Improving about just a little bit a while ago and took on their name just recently last year. So we have a very long-standing relationship with Calgary and our local community, and it's really important at Improving to us because we're committed to establishing and maintaining great relationships with everyone who may interact with our businesses. And so opportunities such as this are reasons why we like to take part. As mentioned, we offer many key services and expertise focused around data, business intelligence, and analytics. As such, we feel our collaboration with the Data Management Conference Canada is quite fitting. So thank you again for joining today. We really do hope you enjoy today's session and the sessions to come. Should you have any questions or want to learn a little bit more about what Improving does, do reach out to myself. I will put my email in the chat box.
Thank you, Brianna. Thank you, and again, it's sponsors like Improving that is actually sponsoring the entire series until our next couple of events here as well. So it's really their support that makes it possible for us to offer the ability to come into a price that actually you can afford. And at a time like we're in COVID and the economic downturn, really critical. So I just want to really again thank Improving. So let's maybe move on to our first speaker, John O'Gorman, who I've known now for a few months, and I really enjoyed actually the conversations I've had with both John and Dave. John is principal and founder of Quantum Semantics Incorporated, and he's been working in the space of data disambiguation now with a strong focus on semantics and language actually as a facilitator to data centricity. So based on those few words, let's just please help me in welcoming John O'Gorman. I'll make you presenter, John.
Thanks very much, Wade, and thank you for inviting me to the forum today. I really appreciate the opportunity. I have to say, the last time I was in a presentation space with Dave McComb, he was tearing up some of my stuff. So good to be separated physically a little bit, Dave. All right. So the title of my presentation today is Language First Enterprise Information Modeling. And as Wade pointed out, I've been working in this space quite a while, but only recently, thanks in part, large part actually, to Dave McComb, discovered the architecture called Dave calls data centric. So this is my presentation. So this is kind of how I think about information. I've been called kind of a contrarian, I guess, and so these categories are kind of stacked that way. Atomic and universal. So one of the premises of the model is that information, regardless what form it takes, is all made of the same stuff, and that the elements and patterns of association are found everywhere. And that's sort of, I'll cover that in my experiences a little bit later in the presentation. The geometry and organic part of it is essentially kind of a nod to, to the physical chemical kind of thing that says, as from my perspective, when you look at the different forms of information, a data record and a document that are semantically equivalent. The only difference is their shape. They've just been stored differently for different purposes. And placing limits on the geometry allows you to extend those shapes into pretty much any shape that you need to make. Taxonomic and associative is again kind of a nod to the graph thing, where classes of information that are universal are also associated with relationships that are also universal. And when you control those two factors, it makes life a lot easier. And then the final one is the relationship between the meaning of data and how it's stored digitally. We've all run into these issues as practitioners in the data and information fields, where you have one artifact can have the same shape, like the word patient can refer to someone in a hospital, or it can also be a sort of a status of a patient person, like not unlike myself. So what I'm going to cover today is a bit of my journey from where I started, and interestingly enough, University of Calgary was where I started my information management journey with Honeywell Multics and those cute little cards, the Hollerith cards with the holes in them. So this is kind of where I went. I was working in the executive information branch at Mount Royal College. It was called at the time, was now Mount Royal University, working with data and files. The big problem they had when I joined in 1987 was it took them 4 or 5 months to do their quarterly executive reports, which was kind of too long. So we started up a process called data liquefaction, where we took all of the operational stores and basically extracted them into something we could manage. Of course, once you start doing that, you realize that your first challenge is to map the differences between the way human resources and student information systems name things differently than, for example, facilities and different kinds of reports. And then we started doing some really nascent sort of data warehousey stuff with dimensional analysis, because we started to see patterns in the data when we took them all apart and assembled them, that those patterns started to repeat themselves. And the fact that they were repeatable meant we could do all kinds of interesting things with reporting, almost sort of on the analytics side that the college could not do before I got there. The second part of my journey, when I left Mount Royal College, I was based in the Bay Area in San Francisco, and I was seconded to a project at BMC Software in Houston. And we got seriously into the content management at a very granular level. I was working with a technical publications team that was doing a lot of topic authoring for their help systems. So in the course of that work, there was a lot of classification and literal sort of translations. I think at one point, they were releasing 27 different product lines in 4 different formats, and they wanted to simultaneously ship them in 6 different languages. Excuse me. So I got into the classification and translations, which kind of added a whole new wrinkle to what semantic meant. And I developed in the course of that work, I developed something called a faceted metadata plan, an approach that says, again, the patterns that we saw in the classification of the content were repeatable and surfaced quite a bit. This connection here between the dimensional analytics on the data side and the faceted metadata on the content side started to get me thinking about a thesis that perhaps all of these classes were the same. And I had this big idea that I call Q6, and I'm using that. I've used that name and that approach for the last 20 years or so. And it's basically a universally faceted classification. So this was my big epiphany, that the data side of a business and the document side of the business were using exactly the same classification techniques, the same dimensions, the same facets. So these are my requirements for a language first model. These sort of, interestingly enough, have sort of developed over the years. I didn't kind of come up with these right out of the gate. It has to be technology and application agnostic. It has to be domain independent, multilingual. So everything I've worked with in the last 12 years has been in multiple languages. And then this is kind of my shtick here, this 100% ambiguity free. And again, anybody who's worked in semantics recognize we have equivalents that can be equivalents of language, equivalents of format, equivalents of structure, homonyms, homographs, all of those sort of things that need to be managed, aliases. And the last one there is temporality. So a big part of this model is how associations work, past, present, and future. Language design, first principles. Again, these were sort of developed over the years so I could talk a little bit more coherently about how this design came about. Inclusive is the first one because a lot of modeling is done strictly with nouns and predicates, or nouns and verbs and relationships. In the Q6 language first model, all of the items, all terms and stuff are first-class citizens. What this one means is that when I take a term or a phrase or a document out of its application, I use an identifier and a classification schema that just classifies it at face value. So patient, for example, is a word that has a definition, it has a class, it has identity all by itself. I don't tie it back to the application at all. Assemblies are using a fixed number of associations, and again, this is for consistency. There's also the precision around specialization and variation. So the rules are precise, but essentially what that means is that you can take any combination that's relevant to a business, and using the same rules across the board, you can get very precise kind of management of those terms and content. Again, I mentioned time sensitive. Temporality is managed both on an item and in associations. And finally, reusability is a huge part of this. This was the big, in tech pubs, even 20 years ago, there was a huge push to reuse content. So a topic that was written once should be reused many times. It's sort of a mantra now in data management, but reuse is a big part of the Q6 model. It says if I already built it and it works, I should be able to reuse it anywhere that it's relevant. So as any of you know, when you're doing this kind of work and you've got this many sort of requirements and constraints, there's two things that can happen. You can build sort of a Rube Goldberg kind of every topic requires a sledgehammer sort of thing. This is taken from the Collier publication. Rube Goldberg was a cartoonist that used to draw these things about, this is the self-operating napkin. So you can build something that's really, really complex. It's really, really large to solve a really, really small problem. This is my aspirational architecture. It's fully integrated at the cellular level, it basically checks all of the boxes in my requirements. It's fully integrated at the very granular level. All the components are made of the same stuff. Functionally distinct but orchestrated silos. This is when people talk about silos busting. Let's get rid of all the silos. In my aspirational architecture, I don't really want to get rid of my liver and my heart and my kidneys in favor of some kind of integrated whole, because I kind of need those. So what I want instead is this concept of orchestration. They all have a particular purpose. In data management, I'll talk about this a bit later. In data management, for example, there is a reason why you separate customer relations and facility management and those types of applications into different places, because they're designed to do specific things. The second one there, the fourth bullet there is allowable but highly constrained physical variations. So height, weight, hair color, all of those things are they're variations, but they're allowable. Care and maintenance improves performance. This should be tattooed on every IT folks around information management, because applications and servers aren't the only thing that need to be taken care of. Intraoperable. So this particular architecture can interoperate with other systems of the same type. So communication obviously is important. And then the last one is getting the right information to the right components at the right time. This aspirational architecture does that, I'm going to say naturally, but there are messaging systems, there are carriers of information and carriers of other things that a body needs to operate in a precise kind of way. So here's what I came up with. The language first elements, there's only 2 of them. I call this an item. I'm going to later call this a quant because it kind of matches my company name, and I thought it was kind of clever. Items are reusable pieces of information. In order to maintain independence, they're classified according to common usage. We've all been in what I call the bun wars, where somebody is trying to put a hammer down and have only one definition for customer. But the way that Q6 gets around that is to say we can agree what customer means in the Webster Dictionary. Now let's decide how we want to use customer in our business. The association part, they're bidirectional relationships between two items. And I constrain that to 6 different types of associations. I'm still working on that just to make sure that I haven't either overdone it or underdone it, as the case might be. But the reason that I constrain these is for consistency, but also because it helps me control translations, and it also addresses that requirement that temporality be included. So the is has can change, events can change that is has from the present tense to the past tense or future tense. So here's the properties. So I'm calling this a quant, which is an atomic unit of communication. These are the properties. Quant types are abbreviations, acronyms, code, just basically a functional classification of how this particular string might be used. And then the Q6 classes, the facet keys are here: who, what, when, where, why, and how. And there's 19 quant classes. So as Wade said, I've been working with this model for quite a while, and so far I haven't found class number 20. So again, this is highly constrained. It has a few different quirks about things like the Y category contains discipline, role, and use. So it's a functional category. It's not tied to motivation at all. So that's the model for items. This one was a little contentious in the February conference in Fort Collins with Dave, but it got some great discussions going. So there's only 6 association classes. Oops, my bad. Let me just go back up here for a second. So the 6 association classes is this quant can be a member of this quant. So obviously this is a class on the right, and this is an instance. This is the is part relationship, the Meronomy sort of relationship. So Calgary, for example, is part of Alberta. Precedent helps manage time as well. So July comes before August. This sounds kind of an obvious example, but this precedent comes in really handy when you're talking about processes. The intersect is kind of the most broad category of association. It says we're not exactly sure if we can make this more precise, but one of the things this intersect relationship handles is the relationship between a Y class in Q6 and a who class in Q6. So this is kind of a model of, say, a business analyst has an intersect with the person, John O'Gorman. Equivalence, I use this a lot. This is not, and in the glossary that I'm going to show you in a bit, equivalent handles everything from translations to expansions of acronyms to things like this, where my.docx and my.pdf, so this is a rendition of that. They're equivalent semantically, but they have different shapes. They have different digital signatures. And then the last one is properties. So if a model warrants it, we can model properties outside of the property collection. They're designed to be read in either direction. One of the things that raised a few eyebrows was the idea that when you read it left to right, so Calgary is part Alberta. When you read it right to left, it's Alberta has part Calgary. So it looks a little awkward at the beginning, but it works to manage associations in both directions. Good so far. So the models had a lot of really warm reception on the business side, not so much on the IT side, because DBAs and sort of what I call more traditional data modelers don't really like this for a number of reasons. The first reason is granularity. A model that's this skinny and this granular is really, really difficult to build using traditional methods. The second one, location, is more of an issue with the, shall I say, the data architects. If they get past this granular part, the business sort of goes, well, okay, so where do we put it? Like, where exactly does this kind of thing fit in the business? And it can be either large or small, but for the most part, the reaction is it doesn't. It's kind of like a platypus. It doesn't really fit anywhere that we can put it comfortably. And the last one there, excuse me, is value. So again, how do we demonstrate value quickly and effectively? How do we do that? So this little comment at the bottom in the course of day-to-day business, people won't let you muck around with live data. So that's not an option. They're not going to let you put all of those properties into their databases. And then the second one there, if you're not adding value as a consultant, you might as well go home. That's kind of one of my mantras, is if we're not making progress and things like that. So the question remains, how do we do this? So enter Dave McComb and the graph kind of approach to things. So the answer to all of those questions, yes, it's granular, yes, it needs to live somewhere, is to basically make it standalone by itself, which that's not redundant. So what I was doing was essentially harvesting business language from structured data and building a data glossary using the quants and the associations. And then the next phase of this is metadata assignment. So now we have these business glossary terms that have dimensionality, they're faceted, and we can assign those metadata values to content. And the last one is basically information alignment, where we can start to extend this same approach. It's extensible and repeatable and is consistent in its classifications to every other information artifact that a business wants to incorporate into this model. The delivery solution, so this is again sort of related to the previous slide. Start small, build something bigger, and add value as you go. This is the minimal viable product kind of approach. I've got a couple of examples there how this is consistent, but essentially the approach in a business is to build a business glossary, start to expand that to facts and documents. We have the tag documents here, and then we get into a full-blown linked data and documents. For those who are not familiar with, FAIR stands for findable, accessible, interoperable, and reusable. So here's the last slide. This is where I kind of wound up with Alberta Health Services and a few other clients. The process really does reflect the architecture. So choose your sources. Excuse me, classify and register. So these are the Q6 registers that you saw in the previous slides. Create a fact registry. This is the graph representation. So these are all very atomic and granular. These fact registries do a couple of things for you. They can build business facts that people in the business can have access to really quickly in one place. The other thing I want to point out here is this reuse part of it. This location here is, this location configuration is used quite a bit, and here I've used it 3 times. The next one is the document registry part. So again, we're using these facts to connect to documents. And I do have a sort of a document orientation here. And that's just because that's what I'm more comfortable with. The visualization part is really interesting because it turns out in my neck of the woods, where there's a lot of companies involved in oil and gas, you can put all of their content on maps, and then you can slice and dice and filter content the same way that you filter data. So this is the display piece, the visualization. Analytics, as I sort of pointed out earlier in the presentation, when you use the same classes for data and documents, you can now include documents as part of your analytics. So for example, if you wanted to start slicing and dicing on certain profiles of customers and you have customer content, you can pull that up at the same time. So that's kind of where I've been. The model is extremely granular, extremely simple, I think. I've been using it for quite a while, and it does seem to work for clients. The business glossary approach now is kind of my way of introducing the topic of data centricity to clients that I talk to about future work. And that's it for me.
Thank you, John. I'll just get back here.
Well, while we're switching over, John, I was sad to hear that you felt like you got savaged last time we were on the stage.
No.
Actually, I enjoy your stuff. We agree, as you'll hear in a minute, we agree on a lot more than we disagree on.
Oh, for sure. I had a great time, Dave. It was all in good fun. It was well played, actually. So I was just giving you a little bit of a rib there. So yeah, it was really good time.
Yep.
Well, that actually brings around a good commentary here. Please do include your questions in the chat. I think that since we do have a panel, we're we've taken this approach of doing speakers and then a panel, so we can actually have this healthy debate afterwards. So please do submit your questions into the chat, and I will pose those at the end during the panel. So with that, I think what we'll do is we will thank you, John, again, and we'll move on to Dave. Now, Dave is someone I've known also for a few months now, and I've had a number of really great conversations with both he and John, and we were actually hoping to have Barry Devlin as part of this, but he's in the process of moving from South Africa to Bristol, and he's trying to buy a house, so he didn't think he would have internet. So we're going to move Barry's talk to probably February. Barry Devlin is a very early pioneer in data warehousing space, so it's going to be an interesting conversation. Dave is president of Semantic Arts and a frequent contributor on TDAN and Dataversity. He's also the author of 3 books, from 2003, Semantics in Business Systems, 2018, Software Wasteland, and 2019, The Data-Centric Revolution. So you can see there's a theme here that definitely matches with what we're talking about today. So with that, Dave, I'll hand it over to you. Now, Dave's been having an issue like I did at event with his Mac and sharing, so I may have to end up sharing, but Dave, let's just try one more time, and then I got your presentation open on my computer.
Yep, and show this window. Doesn't look like it's going to do it.
Okay, well, you just I'm going to get this maximized, and I'm going to share your presentation. Just say next slide, and
yep,
I will take. There we go. Okay, I'm just going to turn on here. There you go. Okay.
Hey,
And it's all yours.
we're going to talk about the future data architectures. So next slide. So I thought I would start with some sort of anchored diagram, and here's a classic one I picked up from somewhere. And this just looks so lovely. You know, you got the data architecture down there at the bottom as kind of the foundational piece, and applications built upon it, and business architecture and technical, and then you get enterprise enablement. Finally, the little capstone there is governance. And it looks nice and it sounds good, but actually this is not it at all. Click once. Despite the fact that there are all kinds of conferences, books, and tens of thousands of people who have data architecture in their title, including probably half the people on this call, click. I'm going to suggest in most large enterprises, there's effectively no data architecture. So now people are going to question that a bit. Click. So if we're going to talk about the future of data architecture, I'm going to suggest a good future would just be to have a data architecture. That might be a nice future. And then click. You know, when all you people that have data architecture in your title say, what do you mean there's no data architecture? Click. I mean, that's sort of like saying there's no Santa Claus. It seems like there's a data, and we all do all this data stuff all day long, and you know, we draw diagrams and build models and go to meetings and be stewards and do whatever we do. But I'm going to suggest most of what's actually going on, and when we observe our clients, click, there's one of 2 things going on that's sort of filling the void. Click. One of them is every data architect worth their salt has a diagram like this. They're all different, but they're all kind of the same. And in fact, what should strike you when you look at this is, you know, it's got ingestion and rationalization and harmonization and all, you know, all good stuff. But stare at this for a minute and think about it for a minute. This is a computer architecture. This is a process architecture. These are a bunch of programs. This is not data at all. It's as if this is we wanted an architecture of water, and somebody gave us an architecture of pipes. You know, pipes are interesting, pipes are nice, but pipes aren't data. The water, the data is the thing that's in the pipe that we really care about. And yes, we should have good pipes and they shouldn't leak and they shouldn't allow contaminants and all that kind of stuff. But we shouldn't fool ourselves that all this stuff is data architecture. This is an architecture to kind of enable something. And by the way, what, as we'll get into in a little bit, it's enabling something that's for the most part not very productive. And this isn't it anyway. But then click. The other thing that's going on under the heading of data architecture these days is mostly data cataloging. And what has been happening over the last 5 or 10 years is companies get more and more data sets, they now call them, you know, whether they take an extract from a mainframe system or they go out on the web and grab stuff. And of course, you know, once upon a time, people had some discipline and they tried to make it conform to a dimensional model or something, but nobody does that anymore. We're just bringing it all in, putting it in a data lake, and then, of course, you realize after you have tens of thousands or hundreds of thousands of data sets in your data lake, many of them are incredibly overlapped, and you have no idea what's the golden version and where's the good one and what, you know. So anybody who's consuming data now has to do a whole bunch of research to find out where's the good copy, what should I rely on, what should I do, where can I find it, which has given rise to this idea of data cataloging, which is also a value-added discipline. But again, I kind of want to suggest that this is a rearguard action, that we're you know, we're like librarians with those little cards, and the card catalog is not literature. We want to deal with literature. What is the actual stuff in those books? What is you know, literature actually all about? That's what data is, not the card catalog. So I'm not saying it's not important, especially nowadays when we have so much diversity and whatnot. But that's my point, that there's not much data architecture in most large enterprises. So click. And you might want to ask yourself, or I do periodically, why isn't there a data architecture? And the reason that there isn't is because there's an application architecture. The application architecture owns the data. You know, this classic 3-tier thing here. We got the user interface, the business logic, the data tier, blah, blah, blah. We've seen this a million times. But what is sort of subtle and stuck in here is, even there's a database down there at the bottom, no application person will allow you to access that data directly. And rightfully so, for like 2 different reasons. One is that, you know, you could violate all kinds of referential integrity constraints that only exist in that code. But the other is that this thing is so complicated that the odds of you getting it right are very slim. So the net of all that is, and you know, if you watch developers develop, they spend very little time thinking about how this chunk of data is going to tie into every other chunk of data in the enterprise. They just go heads down, solving the problem at hand. Let's go. If I need more fields and tables and columns, so be it, and on you go until it passes its test and the user story is complete, and then I'm happy. But as bad as this is, click, there's an even bigger problem. There's not really an application architecture, click. There are hundreds or thousands of them. Every single application in your enterprise has this exact same issue, and every one of those databases is arbitrarily unique. In fact, one of John's terms, you know, I think the it's the ambiguous, I guess, but arbitrary and ambiguous kind of are kitten cousin. So what you actually have in an enterprise is thousands of these application architectures that have co-opted any possibility to actually have a data architecture. Now, people try every now and then somebody tries to do an enterprise data model. We've watched people do that. They typically get to tens of thousands of tables and take years, and then people give up, partly because what's happening while they're doing this enterprise data model is people are out there buying more packages, and every time you buy another package, you get yet another completely arbitrarily different data model. You know, you didn't even have any input in it. It was some, you know, German automotive company 30 years ago that initially set that in place, and here you go. So that's what's kind of preempting having a data architecture. And the other one, nowadays, it's getting worse even faster, because with software as a service, every single software as a service endpoint has yet another data model. And now any middle manager with a credit card can incur integration debt on behalf of your firm. So click. So here's the kinds of differences that people design into these tables. You know, I originally got motivated down this path quite some time ago when I just observed how completely arbitrary data modeling was, and I was a data modeler, you know, and I just solved a bunch of problems. I thought it was pretty clever. But then you'd sit there and look at it, and you'd say, why is it that 10 people designing an inventory application will come up with 10 completely different designs? Why isn't there something that's causing them to kind of come together? Because the problem is, when they do come up with 10 different designs, now you've got 10 data models, now you've got 10 times 10 systems to integrate, and that's, you know, where all the budget goes. So anyhow, here's some of the things that show up in these arbitrarily different things. There's a different name for everything, and half the time they're acronyms or German labels or strange names that don't resemble what they are, or user one, all that kind of stuff. Every system needs to have identifiers, and very often they create their own. You know, I have these local identifiers. We call them hyper-local identifiers. They, you know, create their own structures. They decide whether to have or not have junction records and all that kind of stuff. They implemented different levels of abstraction. They have different validations and therefore different levels of quality. They store things, you know, JSON, relational, XML, whatever it is. So any two of those databases is, even though they appear on the surface to be covering the same domain area, they're as different as they could possibly be. We were at a client. This is a state workers' compensation insurance company. So, you know, kind of a medium-sized company. And we discovered in looking around that they had sort of accidentally implemented accounts receivable functionality 23 times. And they didn't notice they had done that because they didn't call it accounts receivable. They called it, you know, claim overpayment. You know, if somebody stays on workers' comp too long, you have to get money back, or it's a elevator permit that you need to pay, or, you know, but they all had all different names of everything. So you completely obscured from you the idea that, oh yeah, actually, this is all about somebody owes us money, and how come? So anyhow, next. So that's kind of why things are bleak at the moment, but there's hope. The future, in our opinion, revolves around what we call an enterprise ontology. And you can't read this particular one. This is just a sunburst diagram of one of our clients' ontologies, but I hope you can get the essence that there's a few hundred classes here. And we don't show the properties on this particular diagram. But, as one of our clients once said, when we describe this, that this is representing your entire enterprise, and this is a business client, about somebody on the business side, they said, that's something a motivated analyst could learn over a weekend. And you go, yeah, that's the whole idea. Right now, nobody could possibly learn all the data models in a large enterprise, even a medium-sized enterprise. I've got a bunch of statistics on some of these things, but they're frightening, some of them. Yeah, next click. So here's our idea of what data-centric is, and it's not like you either are data-centric or you're not. Most companies are on the journey, or the ones that have started are on the journey, and they're partially data-centric. But we say that application functionality is loosely bound to and I'm going to detail this out in the next couple of slides, but a single, simple, extensible, federatable, shared model. And this, as you'll see in a minute, is exactly the opposite of what is currently true. As we know, application functionality right now is incredibly tightly bound to these arbitrary models. People write code to a particular data model, and so any possible change has a lot of inertia not to happen because of all the code that's affected. So click. So here we're going to break it out a little bit and just go through each of these and sort of outline how the data-centric approach is different than the application-centric approach. So click. This idea in an application-centric, there's a data model per application. So if you have 1,000 applications, you've got 1,000 data models. And by the way, medium-sized companies may not think they have that many applications. Maybe they don't. I've even looked in our own firm. It's a firm of 20 people. We have 25 multi-user applications that are barely stitched together. I mean, it's quite embarrassing. I'm trying to solve that. But so in data-centric, the idea is there's one model for your enterprise. Click. The idea is that it needs to be simple. In application-centric, any one application typically has thousands of concepts, and there's thousands of models. We're always amazed when we go into some of these places. It's pretty much always you can reduce complexity by a factor of 10, very often by a factor of 100. And if you can be in there long enough to take it across the whole sea of applications, I'm pretty sure complexity can be reduced by a factor of 1,000. I mean, it's really pretty remarkable. Okay, click. Oh yeah, click. So extensible, in application-centric terms, there is a rigid, structured data model, and if you want something changed, it goes in this whole change request process and all that. And of course, everybody has to accept the change because there's only one model per app. And if you want to add a field, then everybody gets that field on the form, and they don't want it, and blah, blah, blah. In the data-centric approach, while you have this shared core, the simple core, each group can extend that without disrupting or breaking what the other people are doing. And I'll detail that just a little bit to make it more clear, because I recognize that sounds a little too good to be true. Click. Here's an example from a long time ago, and this is just a handful of concepts we took out of a ontology we did for the Washington State Department of Transportation. And as you might imagine, you know, at Department of Transportation, there's kind of things you'd expect. There's projects and intersections of vehicles, you know, because they're tolling and counting, and there's right of way and roadway and all these other things, including my personal favorite when we were doing this modeling. They described something they called roadside features. And I always thought a roadside feature was the world's largest ball of string, or, you know, a tree that looks like Paul Bunyan or something like that. But in their idea, a roadside feature is anything that's permanently attached to the surface of the earth, and close enough to a roadway that you could hit it with a car. So it includes everything from, you know, traffic lights. You know, you put them there and somebody could hit it, or a big boulder that you haven't moved, or even a tree if it's sitting there. So that kind of give you an idea of these. We call them the covering concepts. This covers actually quite a bit. And click. And then we went out and discovered that somebody had a database of all the fire hydrants in the state of Washington. And of course, it was an Access database, but it had all kinds of funny column headings like GPM. Turns out that was gallons per minute. ALM, that's adjusted lane miles. A phone number. FD is the fire department. And a hydrant. They have little identifiers on them. So in this case, you can, let's see, click. You can extend the green model and say most of the things that we're finding in that fire hydrant database are actual logical extensions to the things we had in the enterprise ontology. So the water flow is actually a kind of a magnitude, and the adjusted lane miles is a location, and the contact there, the phone number is an address, etc. And you might imagine a fire hydrant is a roadside feature, because any fire hydrant that's not close enough to the road to be hit by a car is also not going to be very useful for a fire truck. So that's what we mean by extension. And the people using the extension are borrowing the shared concepts, but they're not requiring anybody to buy into them. Now, click. Here's where it gets interesting. The next little bit is federatable. So in application centric, there's pretty much no such thing as a multi-database query. You know, every once in a while you find these these virtual database products, but for the most part, they're edge solutions. People do not run queries over multiple databases, but this kind of stuff is built in, and it's got some very cool features. So if we click, we'll see this in that previous example. So once we map the fire hydrant database to the local ontology, and then map it to the enterprise ontology, click. You can write, I guess, click again. You can write a query only using terms up in the green, but the system can reach out to, you know, these other systems, and, you know, even if the data stays where it is, you could say, you know, this is meant to say query a RF. I had to abbreviate here. Give me a roadside feature at this location. Now, the person knowing the enterprise ontology doesn't know about fire hydrants, but click. The system goes out, finds that there is a roadside feature at adjusted lane mile 97, and it brings back this information. There's where it is. It has its communication address, and by the way, it is a fire hydrant. Yeah, you know, you don't have to have prior knowledge of what a fire hydrant is. You don't have to have prior knowledge of this whole table and doing joins ahead of time, and all that work we typically do, and all the stuff that makes data work hard is just gone. You know the simple little thing, it drills down, brings it back. Bob's your uncle. Click. And then finally, you know, application centric, there's no concept of sharing, not really. Mostly we copy data from place to place and change its format and all that kind of stuff. Data centric is really all about sharing by design. In fact, one of the CEOs to one of the triple store vendors, a guy named Jan Zossman, had this great line the other day. He said, a typical application developer will invest about 0 neurons thinking about how what he's doing here is going to affect data and the rest of the enterprise. Whereas an ontologist or semanticist or something is hopefully going to spend about half of their neurons worrying about that. And that's what this is. Click. I just want to give a commercial for something. If this is of interest to you, there's a website out there that we started a long time ago called the datacentricmanifesto.org. It kind of lays out some of the principles of this. And click. Interestingly, I went out there over the weekend when I was making these slides, and there were 750 people have signed it. And there's very thoughtful things that people say. A lot of people buy into this. They're very frustrated because it's hard to get this implemented because the application centric approach is so entrenched and developers so fall back on what they're used to and all this. So it takes a lot of discipline to do this. But if you buy into this, you're not alone. There's a lot of people. It was 764 this morning. If you guys all go out there, we'll get pretty close to 1,000 here pretty soon. And then click. So who's doing this? There's 2 main categories of people that are doing it, at least that we know of. Pretty much all the digital natives are doing this. Google has their knowledge graph, which was originally MetaWeb, and they acquired that company, took it into stealth mode for a while, and about 4 or 5 years ago, when search all of a sudden started returning results instead of documents. I mean, that's what that was all about. It's really pretty fantastic. Amazon has their product graph. That's almost all the recommender stuff is based on this kind of technology. Microsoft, LinkedIn, it's all a graph. I didn't mention much, but the preferred implementation of everything I'm saying, it is graph databases and semantics. We've seen people implement data-centric with traditional and relational database. It is possible. It's pretty hard. It takes a huge amount of discipline to do that. And I forgot I guess that was Facebook down there in the lower right. So, all the digital natives have this at their core. And then click. And a lot of, these are our clients. They're, for the most part, all on the journey. They haven't totally converted over. It takes quite a while, but that's my spiel. Click. I think that's my last. Oh no, there it is. That's my last slide. I think a lot of people have heard this before, but it's absolutely true. I think we know what the future is. I think we know that it's going to take people a heck of a long time to adopt this, and many just won't. So there you have it.
Thank you, Dave. Just gonna disconnect myself from all my stuff here now. Okay. Dave, thank you so much for that. Actually, it was really interesting, and this is actually a fairly new area to me. So I'm just going to look at I saw there's some chats here. I'm going to welcome, again, the audience to submit questions, but I'm going to start with a couple actually for both you and John here. So we'll move on to the panel discussion. So it's fairly new to me, this the data-centric approach, and philosophically I draw parallels with both data federation and data management married to an integration layer. So I'm curious, how does data-centric architecture differentiate?
Yeah, there are people who are doing things that look a bit like this. Like, I don't know, Denodo is a very popular platform right now, which allows you to abstract your API from the APIs of the various systems you're talking to. And actually, that's a great that's a great thing to do. But what we suspect is going to happen in most shops, which was the same thing that happened for service-oriented architecture and various other approaches, was seemed like a pretty good idea. Like with service-oriented architects, the idea that you could send messages back and forth, and therefore these systems couldn't be tightly connected to each other. But what actually happened was people just took their existing APIs and put them on the bus as they were, and forced everyone else to deal with it and ingest it. So it just became the sum of all complexity. So our take is, no, you need to start with something simple and say, if this is our shared model in the enterprise, and whether you're doing service-oriented architecture or Denodo or anything, start with that and ask yourself, where do I find that stuff in this system?
John, can I get you to turn on your the camera if you can? And
Sure.
I'm going to bug you about your language first approach. And can you dig into that a bit further and how it's an important shift to how organizations view their data?
Sure. So I think the challenge has always been, at least the holy grail for a lot of companies. It's like Dave said, the application-centric thing kind of keeps these silos kind of cooking along. But most business users understand that hopping from application to application, even if it's something like SharePoint to like Box as a content, or you're doing customer relationships, hopping from application to application is an enormous waste of time. So the language first. The other thing that's a big time sink for me that I've seen over the last 20 years is enterprise search. So when you start talking about a language first approach and a business glossary as your starting point, users don't care where the language is coming from. They just want to know, for example, what an acronym means. Like a new hire, for example, might come into my current client and say, I don't know what CFA means. I don't know what BAM means, or what does FAM, what does FAM mean? And they're not looking, as Dave correctly pointed out, they're not looking for content. They're not looking for documents. They're strictly looking for information. So the language first approach says, okay, if they're looking for information and the information can be as granular as an acronym, how does that boat, like, how do I organize the rest of the enterprise to make sure that once they find the acronym, so for example, FAM stands for Facility Asset Management, they can actually traverse into the content around that acronym without leaving the site they're sitting on. So it's, I use this analogy quite a lot. It's kind of like a digital marketplace. If I'm looking for ingredients for my dinner, I don't want to have to go all over the store. I just want the stuff to come to me. So part of the, and I'm relatively new to the data centric concept. I really like it because it fits in with that approach. So again, the language first essentially says, practically speaking, what are business users looking for? Information. Do they care how it's packaged or where the package sits? No.
Right.
Really interesting. And of course, you could both kind of pipe in, because I do think that there's going to be some debate here. So by all means, feel free to pipe in as well if you wish. Dave, actually, in one of your articles on TDAN, you wrote, and I quote, "Data is a primary and permanent asset, and applications come and go." Now, you obviously explained that to some extent, but can you also maybe unpack that a little bit more?
Yep. You know, I think a lot of people are lulled into believing that the application is the important thing. You know, that we have these screens and we type stuff in and blah, blah, blah. But actually, the data that's behind it is what's really going on. If it's an inventory control system, what we really care about is accurate inventory balances and average costs and serial numbers and all that kind of stuff, and how it got there isn't really all that important. And right now it is because the application owns the structure of the data, and that's the only way for it to get there. And by the way, every time somebody goes to do a system conversion, they decide, well, we have to convert all this data from what it was to how it's going to be now, and then inevitably, as soon as the project gets started, somebody goes, oh my God, the quality of this data is terrible. Well, it's not so much that the quality was terrible. I mean, it was probably okay, and part, it's not all data is of great quality, but the truth is, the new system has different requirements for constraints and validations and structural things and everything else, to where you end up launching this giant project just to get the data to the way the next system would like to see it. Whereas really, the users would just be happy if there was a application independent way of knowing about inventory and quantity in hand and all that kind of stuff. And an application could do an economic order quantity, put it in there, leave. If I never saw that application again, I'd be fine,
Yeah.
So I'd like to ask you both a question now. So this is actually a question I asked Dave. I think you in our kind of pre-event interview that we posted on DMC. So let's talk about the future state. If an organization goes all in, what does an organization look like? So if an organization moves away from the application centric and actually adopts this vision like full scale over, of course, a number of years, you'd have to, it's a bit of a revolution. What does it look like?
That's great. I'll let John go first because I answered this before. What's your take, John? And then I'll.
Yeah. Oh, that's a great question. I think, okay, from two perspectives. I think one from the business perspective, that they're a lot more adaptive. They're a lot quicker on their feet because they don't have to spend half their time, for example, looking for things. Or in a mergers and acquisition scenario, for example, the task then is to make sure that the data is all integrated independent of the applications. So I think that's being more nimble, I think is the right word for that, because again, you use the same data-centric model. Data can come from anywhere. It can come from standards bodies. It can come from inside, outside. Doesn't really matter. From a technical perspective, and again, Dave and I have both run into the same resistance. I think I'm going to borrow Dave's phrase. I think the balance of neurons dedicated to making sure the data all works together goes way, way up. And I think a lot of this spend on technology goes way, way down.
Yep. Yeah, I think about 37% of the worldwide IT spend is up for grabs, and worldwide IT spend is somewhere around $3 trillion. 37% of that is, I don't know, 700 or 800 billion, which is application packages, custom software development, middleware, and systems integration. Take those huge, and as you see the end game, you start realizing, gee, if each person just has a single, we refer to a URI, but just think of it as an identifier, and then there's schemes for understanding that different systems have had different identifiers, but the fact that you have this single representation, a simple model for how to describe things, everything gets simpler. To do an AI project, suddenly, instead of casting around in this giant data lake and looking at thousands and thousands of data sets, all of a sudden you've surfaced it all up and said, no, here's the key concepts and here's how they're related.
Right.
So I'll give you a couple of case studies that maybe are kind of interesting. So Schneider Electric, we did this for their product catalog, and Schneider makes about 1 million parts. They're very complex. You know, it's industrial scale electric devices. You know, circuit breakers and relays for electric trains and all that kind of stuff. And the first motivation was just to get this information from the current catalog into a more flexible, simple environment. We were hoping to simplify the way we did product configuration, and we did that actually. What was what was interesting, we weren't predicting this. We went back and kind of looked. The existing system had about 700 tables and about 7,000 attributes. So, you know, not only was it the actual technical characteristics of every part, but it was, you know, what markets were they being offered in, and what was the price, and how were they displayed on the website. So everything about the product. But what was surprising was when it landed in the knowledge graph, there was only 46 classes and 36 properties were populated. And yet it was all there. And we ended up with a partner building a configuration engine. So it was completely obvious that there was nothing missing, because if there was anything missing, this configuration thing wouldn't have worked. But what I thought was the more interesting, in the middle of this, they said, oh, by the way, we acquired this company and we'd like to see if you could, you know, get their data in. Okay, and we go and look, and they have a system that's also complex, not as complex as theirs, because they were making mostly residential, you know, these face plates and light switches and that kind of stuff. So we studied it for a while and discovered that we had to add just a handful of things. They had these aesthetic groups, you know. So if you're in a house, you worry about whether you put ecru with ivory or not. Nobody cares about ecru or ivory, but you know, anyhow, we go bring the data in, run all the same kind of queries. It works great. And then all of a sudden we discovered that they had acquired these guys 10 years ago and never integrated it because it was too hard. Because if you got one system with 2,000 concepts and another one with 7,000 concepts and they're not the same, way too hard.
And the cost of that kind of misalignment as well to an organization are immeasurable.
Yeah.
Well, and there's a stat out somewhere, I'm not going to quote it because I won't be accurate, but something like 30% of M&As fail because they can't integrate the IT systems.
Yeah, right.
So further to that concept of kind of going all in, have you seen a deep, I mean, I think that you just kind of answered this in a sense, Dave, but have you seen a departmental or divisional adoption of this, whereas the rest of the organization is still working with the kind of the application, but how do they work together at that point? You have one that's gone data centric, the others are still relying on applications, and how are they integrating, connecting? How are the business processes being sustained?
For the most part, you know, there's still legacy systems. So you take the data out of the legacy system, put it in the knowledge graph. Any of the future stuff can run off the knowledge graph.
Right.
And so you're just kind of running in parallel. Now, hopefully, and this is a pretty slow process, I have to say, but in some ways, a knowledge graph is sort of analogous to a data warehouse, except there's one important difference, and that is a data warehouse is completely dependent on the source systems that are feeding it. In other words, there's nothing in data warehouse technology you would ever build new functionality directly on top of the data warehouse. Just doesn't work. But whereas the knowledge graph, you can actually build new functionality. And what we're starting to do now is build, you know, direct updates, and what we're starting to carve away at some of these legacy systems a little bit at a time. You know, but it'll take a while.
Yeah, agreed.
So it's an evolutionary process, I think,
Yeah.
and being with your clients right now. So now this is a great opportunity to actually get into it, actually. So I'm really curious about this next question, because this was some of the content of our pre-event, you know, communications and you know, three-way talks and so on. So John, actually, you've suggested that the approaches that you and Dave take to data centric are actually really quite complementary. With the his approach through his just ontology, you with your language first, Dave with the semantics. Can you maybe expand on that a little bit, or maybe both of you if you can?
I'll try first, Dave. So where I see the overlap, and this was really evident from reading Dave's book and being down in Colorado in February. The classes that we're using, there's almost a 90% overlap between the Q6 classification and GIST. Dave takes, the difference is that, so that's the intersection part. Dave takes his model further than I have in building an ontology, a full-blown ontology. So it's also where mine is coming up to web compliance. Dave's been web compliant for quite a while. So the overlap to me is on the classification part. And you can only use something that works for so long. If it stops working or it breaks down or gets too complex, then you have to stop it and try again. But I think the fact that both Dave and I have been using this particular classification for a while now, and it works everywhere. Like I've been in the last 10 years, I've been in 6 different verticals in the Calgary area, from healthcare to education to oil and gas, financial services, and one other run I can't recall. The classifications work everywhere. It's really kind of cool to come into an organization with that in your back pocket. So I would say that's the biggest point of overlap, and the two major differences.
Yeah, no, I agree completely that we continue to be surprised. You go into different industries and you go, oh yeah, you also have people and organizations? What a surprise.
You don't have locations too, do you? Oh, wow.
Yeah. But obviously every industry, you have to add some stuff, so
Sure.
healthcare, you have to add encounters and conditions and diseases and stuff that most everybody else doesn't care about.
Yeah.
But
again, sorry.
have heard you boil down the complexity of Enterprise X to 19 classes. I find that absolutely fascinating. Sorry, what were you going to say? I cut you off there.
Oh no, that's okay. I was just going to point, just to say by point of illustration, those overlaps. Dave made a great point about healthcare needing its own sort of language, its own dialects, if you will, the same classifications. But in health and safety, if someone has an accident and they've had an ammonium nitrate issue and they don't know what to do with it, the healthcare data store will know. You know what I mean? Like those are the kinds of overlaps where you start to see synergies between organizations because the classes mesh. It's really not that difficult to make the data work together.
Yeah, as long as the workplace and the healthcare providers can agree that there is such a thing as physical substances, and that ammonium nitrate is a physical substance.
Yes.
Now, each of them may know more about that than the other one, but God, if you could just get to that level and you got an and they both know what an exposure means.
Yep. And they know what treatment looks like.
Yep.
Yeah. And they're both interested. They're both invested in making that seamless.
Right.
And the funny thing about that too is, from my perspective, again, in my experience is, my dad used to say, when you're selling something, you really want to get to yes somewhere. And as Dave said, if you sat, say, an oil and gas company, health and safety experts in a room with Alberta Health Services, for example, and the only thing you could get them to agree to was that ammonium nitrate is a substance, you have a latch point.
Yep.
It only takes one. And then they can have their own little dialects on either end of that. But when it comes to treatment for ammonium nitrate exposure, they can agree on terms and they can agree on at least one class. So, hey, it's simplifies things enormously, right? And Dave makes a great point about, mergers and, acquisitions of companies. It's a huge, huge problem. But again, you don't have to overlap the whole thing, which also makes it interesting proposition for companies to say, look, I'm not going to spend a year and a half doing this. I can integrate some things like location and people and let's just say, for sake of argument, physical things in a really, really short period of time.
Right.
And the Q6 model basically says we don't care if you call them different things. You know, ammonium nitrate, I can't remember let's just say it's NaCl for sodium, like sodium chloride or whatever. You call it salt, I call it NaCl, we can make those equivalent.
Mm-hmm.
And then all of a
Right.
sudden you've got, okay, now I've got a bridge between physical materials and, you know, all kinds of interesting activities and storage things and, you know, on the other end. So it's a really powerful model. It gives you a lot of confidence going into engagements that you're not gonna, or that, to my point on one of my slides, that you can deliver value very, very quickly. And then you can keep delivering it as long as they want to keep you, or more importantly, you can teach someone else how to deliver value.
No, that was a great example of you only have to get them to agree on one or two things. You know, so
Mhm.
most approaches, everybody has to agree on some big complex model.
Right.
Just agree that there is such a thing as physical substances, and that here's one of them. Oh, okay.
Yeah. We also see this a lot in sort of data quality initiatives and, you know, the the data governance types of approaches where we're all going to agree that customer, for example, means exactly the same thing to everybody.
Yeah.
I have a scar right here
Yeah.
from somebody throwing a hard disk at me saying, well, get out of the room because you're just causing trouble. So those kinds of things also, that's kind of the flip side, right? Because those kinds of things kind of go away. If you can agree that customer has a definition, let's just take, for example, we're going to get everybody to sort of nod a little bit on the Merriam-Webster definition of customer. Okay, can we just generally agree? But then the arguments start between marketing and sales and all those kind of guys. We're saying, yes, those are adjectives that qualify customer, but they don't change the definition. So put a pin in customer. Tell me how you're going to qualify current, say, let's just say, for example, current marketing customer or current in-country marketing customer. Those are all individual language first terms that can qualify but don't alter the definition we all agreed to a month ago. And
Right.
then what happens is all the pitchforks and torches go away and people say, well, okay, so you're going to give me marketing customer, and then the rules come out to say it's like ordering. You're in a French restaurant, and you're of, let's just say, I don't know, Tibetan descent, and you're only speaking German. You're going to have a bit of a problem, right? But once you agree on a certain term and things like that, then you can obviously, you know, you can make sense of things. So, yeah.
Yep.
I think I've got time for about one more question, and then we can do the wrap up. And Dave, I'm curious about you. You've written 3 books in this domain. You've been thinking, talking, imagining, and writing about this since well, at least 2003, which was your first book. I'm curious how your perspective, your language, and your approach to data science centricity has changed over the years.
Oh yeah. So we very first got started in this idea in the early 90s. And there's just a handful of articles. It was before the semantic web or any of that. And we started incorporating them into our design. We're trying to be a sort of sensible. And then one day we were in this .com startup because it was the 90s, you know, as you do. And one day we're at the whiteboard and we created a semantic model of what an application is. So, you know, what's an application? What if an application was not code? What if an application was data? What would it look like? So we drew this thing, then we built it, actually got patented it and all that. You know, people call it model-driven development. And built a bunch of, actually it was healthcare products at the time, in the late 1990s. But we had to go public in late 99, and we got dragged out into the spring of 2000, and game over. And so all of our intellectual property and all that architecture and everything was in the smoldering ruin of our .com, which is when we started the new firm, Semantic Arts. And we thought that bringing this design discipline to firms would be what they needed. So for about 7 or 8 years, we were pitching semantics. Nobody was catching. So we would just do, feasibility studies and strategic plans, all this. But we were honing our craft in the background, getting better and better at it. Then people actually started asking for it, amazingly. Then we discovered they didn't do anything with it. We give them ontology and design even an data-centric architecture. Didn't do anything with it. So about 5 years ago, we decided that we're going to have to hold people's hands. We're going to be in the transformation business. We're going to have to take them through that process. And it was that kind of led us to this idea that it's data centric. And so that's where that came from.
Really interesting. Guys, I'd like to thank you both very much for the run-up, the interviews you gave, the pre-discussions we've had, and the work that you put into your sharing your knowledge and expertise today. DMC, just in general, I want to speak now. DMC started presenting conferences in 2015, and it was really around presenting just this kind of content, really thought-provoking content to allow professionals to learn and make it very, very democratic access to knowledge. And really, let's just admit it, COVID sucks big time, but it's allowed actually DMC to bring in expertise from actually global expertise, as well as audience from around the world as well. We had speakers and audience from Europe in our last event. So it's been great, and we really do this to lift up the ICT industry in Alberta, in Canada, and now we can contribute also globally, which is a great opportunity. I'd like to thank again Improving for ongoing support. Again, they've been supporting the Calgary conferences and now this entire series since 2017 was our first conference. So I really appreciate their support. So Brianna was going to put her email in chat, so please do contact Brianna if you want to learn more about improving services there. This has been recorded. We will be sharing the link much more rapidly than last time. So hopefully within 24 hours. We had an issue with the processing on GoToMeeting last time, but we will be sharing that up promptly to you as well. So you'll have this to be able to refer back to into the future, and we will be sending you also a surveys, because the feedback's important. How the audience is responding, and if it's valuable, we'd like to know. John and Dave, thank you very much again, and also thanks again to Improving. Thanks.
Thanks, Wade. Thanks, John.
Thanks, Wade. Thanks, Dave. Good to see you again.
Likewise. Take care.